Welcome to Brain Vision.
So we have a thin, uniform rod. We'll say mass of 0.40 kilograms. So this is given. And then we have the length of the rod equaling 60 centimeters, or we can just immediately convert to 0.600 meters. And you always want to keep your significant values. So the moment of inertia, for A, we can find the moment of inertia quite directly because the I of rod about an axis through the center. So these are common moment of inertia formulas for common objects, essentially. And a thin uniform rod is common in the sense that we have a formula for it, and this is specifically the formula for an axis through the center. And this is going to be I equals ml squared over 12, or 0.4 point, or rather 0.6 squared all over 12, and this is going to equal 0.012 kilograms meters squared. For B, you use the exact same. Rather, for B, the engineer says, okay, we're going to bend this rod into we're bending this rod into where the vertex has an angle of 60 degrees in order to reduce the moment of inertia. So we can see if it actually does. So we'll have I equals ml squared over 3. And this is going to be considered I of a rod where about so this would be about an axis through one end. We'll say one end, just to be more specific. And we have two rods because once you bend the initial rod into the 60-degree V shape, it is considered two rods. So here it would equal 2 times and then m over 2, because again, one rod only has the mass of half of the original rod, times L over 2 squared. And this would equal 2 times 0.4, 0.6 squared, and then over 2 times 2 squared, which will be, this would be over 3. I forgot. You carry this one over. We carry this factor of 1 over 3. So it'd be 2 bars, and then 2 times 1 over 3, 2 over 3. So it'd be 3 times 2 times 2 squared. And this is going to equal 0.012 kilograms per meter squared. So essentially, by bending the bar into a V shape with the vertex having 60 degrees, it doesn't change the moment of inertia at all, because as you can see, both of these values are going to be equal. So you have to manipulate the bar in some other way in order to reduce the moment of inertia. But again, once it's bent, the main thing to realize here is that you have to apply the moment of inertia for two identical rods, and then we're using a different moment of inertia formula because we're not rotating about an axis through the center anymore. So bending it into 60 degrees won't change the moment of inertia again. That's the end of the solution. Thank you for watching.